Good morning, math. Now, let's try another problem. As shown in the figure, inside a rectangle that is 8 units tall and 7 units wide, 5 congruent squares fit perfectly with no gaps or overlaps. What is the side length of each of these 5 congruent squares? All right, let's get started. It's a bit troublesome to think directly about the square that's placed diagonally. So instead, we'll look at a right triangle like this. In the diagram, I've shaded a right triangle in blue. Let's call the horizontal side A and the vertical side B. This right triangle can actually be placed in several different locations within the figure. Once we do that, we'll be able to express both the height and the width of the outer rectangle in terms of A and B. First, the height of the rectangle is 8, right? So let's think about how we can express this 8 using A and B. That will be our starting point. To do that, we will place several right triangles that are congruent to the one we just drew. For example, we can place one right here. Since we only need to focus on the vertical lengths, I'll label only the vertical side. The vertical side of this triangle is B. Next, if we rotate the right triangle 90 degrees, we can fit it in this position as well. In that case, the vertical side of the triangle becomes A, and we can place another one here. The vertical side there will be B. Finally, we can also fit one more triangle here, and its vertical side will be A. Now, if you look at this whole setup, the height of the rectangle is completely expressed using A and B. We have 3 B's and 2 A's stacked vertically. So the height becomes 2A plus 3B. Since this height is 8, we get the relationship that 2A plus 3B equals 8. Now let's use the same method to look at the width of the rectangle. First, I want you to focus on this part right here. Look at the 2 segments marked in red, A and B. If we take the difference between these 2 lengths, we get the distance between the 2 light blue horizontal lines below, which is B minus A. Next to that, we have another right triangle, and its horizontal side has length B. Now, let's continue placing more right triangles. We can fit one here, and because it is rotated 90 degrees, its horizontal side is A. Then we rotate another one and place it here. So the horizontal side becomes B. Finally, we rotate one more triangle and place it here. And this time the horizontal side is A. Now we've filled an entire width of the rectangle. So how is the width expressed using A and B? We have 3 B's, 1 negative A, and 2 positive A's. A negative A combined with 2 positive A's is the same as having just 1 A. So the total width becomes a variable A plus 3B. Since the width of the rectangle is 7, we get the equation. The variable A plus 3B equals 7. Now, solving the 2 equations we found earlier, we get the variable A equals 1 and B equals 2. The side length of each square is equal to the hypotenuse of our right triangle. So, by the Pythagorean theorem, the length is the square root of 1 squared plus 2 squared, which is the square root of 5.